In a bag, there are three different colored balls. The size of the blue ball is 50% larger than red, and green is 25% larger than red. Then blue is what percentage larger than green? Now, there are three different balls which are compared here. So let's start with the first case, blue and red. So what is given? Blue is 50% larger than red. So if we assume red as 100% in size, what would be the assumption for blue? 50% larger, right? So we can assume that the size of the blue ball is 150%. Now simplify. This would become 3, this would become 2. So the ratio between the blue and red ball size is 3:2. Similarly, there is also one more comparison. Green is 25% larger than red, right? So green is 25% larger than red. So if we again assume red as 100% size, what would be the size of green? 125%, right? Now, if you simplify this, this would become 4 and this would become 5. So the ratio between the green and the red ball size is 5:4. Now we have got the ratio between blue and red, green and red separately. Now let's try combining them into a single ratio. So the ratio between blue and red is 3:2 and the ratio between red and green is 4:5. So we are just flipping these two terms to get the ratio between red and green. Now use the Z multiplication. So 3 4s are 12, 4 2s are 8, 2 5s are 10. So the ratio between the sizes between blue, red and green is 12:8:10. And as we can see, it's reducible, right? So what would be the final ratio between blue, red and green? 6:4:5. Now what is the question? Blue is what percentage larger than green? So comparing the number of parts between the blue and the green balls, we can clearly see that blue has one extra part out of the 5 green parts, right? So what is 1/5 in terms of percentage? 20%, right? So blue is 20% larger than green. Now the same question can be done in a quick time using a simple shortcut. What is basically compared here? Blue ball and a red ball is compared, right? So blue and red, and what is the comparison? Blue is 50% larger than red. So if we assume the size of red as 100, the size of blue can be assumed as 150. Similarly, green is 25% larger than red. So the ratio between green and red would be 25% larger, right? So if we assume the red size as 100, the green can be assumed as 125%. Now normally what will we do? We'll try to simplify the ratios, right? But since the common element in both the cases is the red ball and their values are exactly the same, what we can simply do here? We can just write down a common comparison in this way. So blue 150, red is 100 and green is 125. Now try to simplify this directly. So we'll get probably 6:4:5. The same answer which we got in the previous steps as well. Now the same old idea. We need to find out by how much percentage blue is larger than green. Now look into the ratio parts between blue and green. Blue has one extra part out of the 5 green parts, right? So one extra part. What does that mean? So 1/5 more than that of green, right? So what is 1/5 in terms of percentage? 20%. So blue is basically 20% larger than green.